Rutherford's alpha ray scattering experiment. After the discovery of fundamental particles, that is electrons and protons, a problem was arised, that is how these fundamental particles are arranged in a small place in an atom, because atom is the smallest particle which cannot be seen with our naked eye. So in such a small place, how these fundamental particles are arranged? Because electrons are negatively charged particles and protons are positively charged particles. There are certain repulsive forces that exist among the same charge particles, and there will be an attractive forces that exist in between electrons and protons. Irrespective of these forces, how this much number of particles were present in a minute place called atom. So to find the secret behind the arrangement of these particles in an atom, so many scientists have conducted so many experiments, but a successful experiment was conducted by Ernest Rutherford. In this experiment, Rutherford has taken a radioactive element radium as a source of alpha particles. This radioactive element was kept in a lead box, and the alpha particles emitted from this radioactive element was allowed to pass through lead plates which are having some slits. And these alpha rays were allowed to fall on the thin gold foil. Around the gold foil, a circular screen was arranged to identify these alpha particles. This screen was coated with zinc sulfide. When alpha particles struck on this screen, we'll get scintillations. With the help of those scintillations, we can identify the position of alpha particles, that is, in which direction the alpha particle has traveled. The microscope was also arranged to identify these alpha particles, that is, to record the position of these alpha particles. This alpha ray scattering experiment, Rutherford observed the following three things. That is, most of the alpha particles pass through the gold foil without any deviation on their path. Some alpha particles are reflected in different angles. Out of 10,000 or 20,000, only 1 or 2 alpha particles have maximum repulsion and reflected back on their own path. From these three experimental results, Rutherford concluded the following. That is, most of the alpha particles pass through the gold foil without any deviation on their path. Indicates that most of the space in an atom is empty. Let it be the atom. Most of the alpha particles are passed through the gold foil without any deviation on their path. Indicates that most of the space in an atom is empty. And the second observation is, some alpha particles are reflected in different angles. Some alpha particles are reflected in different angles. Alpha particle is a 4 units mass and 2 units positively charged particle. 4 units mass, that is heavy mass, and 2 units positively charged particle. Repelling means a positive charge more than its charge and a mass more than its mass may come closer to the alpha particle. Then only an alpha particle can repel. Suppose if only one proton is present isolatedly, it cannot repel alpha particle. Rather than the proton will repel. But here proton is not repelling. Alpha particle is repelling. Alpha particle can repel only when a particle which will have more charge and more masses came into its path. Then only it changed its path. That means the whole positive charge and mass of this atom is concentrated at a minute point. This minute point is said to be nucleus, and probably this nucleus may be present at the center of the atom. So, alpha particles which are away from this positively charged nucleus will pass through the gold foil without any deviation on their path. So, when this alpha particle is away from the nucleus, there will be no change in its path. But when it comes closer to the nucleus, then there will be a repulsion and change its path. So the magnitude of repulsion will depend upon how close it is. That means if it come closer to the nucleus, there will be more repulsion and there will be a more reflection. That's why most of the alpha particles are reflected in different angles. Those alpha particles which are directly bombarded at the center of the nucleus will have maximum repulsion and get back on their own path. Here we have three results. That is, when alpha particles pass focused on the gold foil, most of the alpha particles pass through the gold foil without any deviation on their path. That means most of the space in an atom is empty. Some alpha particles are reflected in different angles. That means the whole positive charge and mass of an atom is concentrated at a minute point, which is known as nucleus. Probably it may be center of the atom. So those alpha particles which are come nearer to this nucleus will get repelled and change their path. That's why they are reflected in different angles. Those alpha particles which are directly bombarded on the center of the atom will reflect back on their own path. From these three conclusions, Rutherford makes a new theory to explain the structure of an atom. This theory is known as planetary model of an atom. Rutherford's planetary model of an atom. Rutherford's planetary model of an atom. From the results of the alpha ray scattering experiment, and after analyzing the results, Rutherford proposed that in any atom, the whole positive charge and mass of that atom is concentrated at a minute point called nucleus. Minute point called nucleus. Because at the time of this Rutherford's alpha ray scattering experiment, neutrons were not discovered. But he imagined that certain other particles with certain mass may also present. They may also present along with these protons in the nucleus. Now, the negatively charged electrons will revolve around these positively charged nucleus, just like planets revolve around the sun. We know in solar system there are nearly 9 planets which are revolve around the sun. Like that, in an atom, the electrons will revolve around the nucleus just like planets revolve around the sun. So what is the purpose of this revolution? Because we have already discussed there are certain attractive forces between oppositely charged particles. This nucleus is a positively charged particle, whereas electron is a negatively charged particle. If electron is in a stationary mode, it should fall into the nuclear attraction, and ultimately it will fall into the nucleus, and atom should decay. So to overcome this attractive force, this electron will revolve round the nucleus. What happens? What is the use of this revolution means? When an object is revolving in a circular path, from its center, certain force known as centrifugal force will arise, which pushes the object away from its center. So, due to this revolution round the nucleus, a centrifugal force will arise, and this force will push the electron away from the nucleus, so that this electron will escape from the nuclear attraction, which is known as centripetal force. The force which pulls the object towards its center is said to be centripetal force, and the force which pushes the object away from its center is said to be centrifugal force. Because of the nuclear attraction, there is a centripetal force. To overcome that centripetal force, the electron will revolve around the nucleus, and because of that revolution, a centrifugal force will arise, and these two forces are equal in magnitude but in opposite direction, keeps the electron at a specific distance from the nucleus. He explained like that. At that time, almost all scientists were accepted his proposal, but later on, after the development of these electromagnetic theories and all these theories, it was found that when a charged particle is revolving around an oppositely charged particle, it continuously loses energy. If it continuously loses energy, this electron path will be a circular path, and ultimately the electron will travel in a spiral path, and ultimately the electron should fall into the nucleus. But it was not happened. That means the proposal of Rutherford is applicable only when there is no charge in these two particles. That is, if nucleus is neutral and electron is neutral, Rutherford's proposal will be acceptable. But here, a negatively charged particle is revolving around an oppositely charged particle. So if a charged species is revolving around an oppositely charged species, it continuously loses energy. If it continuously loses energy, it should travel in a spiral path but not in a circular path. If it travel in a spiral path, in one day or other day, it should fall into the nucleus and the atom should decay, but it was not happening. So Rutherford was unable to explain this. That's why Rutherford's theory was failed to explain the structure of an atom completely. But the idea regarding the nucleus that was given by Rutherford still stands for the science. So this is the main foundation that was laid by Rutherford to explain the structure of an atom. Rutherford's planetary model of an atom is failed to explain the spectra of hydrogen atom. What is a spectra? Why we have to depend on spectra to identify the structure of atoms? Before going into these spectra, first let us observe the properties of light. We all of us know if anything is not visible to our eyes, what will you do? Suppose if I ask you to search for a thing in a dark room, what will you do? Tell me. Yes, we'll take a torchlight and we'll focus the light to search that object. If this light was fall on that object, and when it reflect back onto our eyes, then only we are able to identify that particular object. So, suppose this duster is visible to our eyes. It is visible to my eyes and your eyes also. So here, what is the role of light here? Suppose if I put off all these lights and close the doors of this room, the room will become dark. In such cases, you don't know whether in my hand it is a duster or a textbook or a chalk piece or something else. So, if it is visible to our eyes, the main function of light here is, the light is falling on this object and reflect back to my eyes, then only I was able to see this object. Similarly, while observing the structure of atom also, light has its role. So let us observe first the properties of light. Properties of light. Light. Light is nothing but an electromagnetic radiation. Light is an electromagnetic radiation. The generation of this light is due to the vibration of a charged species in magnetic field or vibration of a magnet in electric field. This light will be generated because light is one form of energy. Energy is in different forms. In the form of heat, in the form of light, and so many ways. So light is one form of energy and it travels in a straight line. This we call it as a path of the light. Along the path of the light, these electric and magnetic fields will distributed like waves. So these two fields are similar and perpendicular to each other. See, let it be the path of the light. This is the light. So if it is the path of the light, so here you are finding some waves, wave-like structures. These are the waves. So here, if this structure indicates the electric field perpendicular to this field, this is perpendicular, this one, if you tilt like this, perpendicular to this field, you have a magnetic field. Magnetic field is also similar. Both are similar, but they are perpendicular to each other. See, but they are perpendicular to each other. So the properties of light will depend upon the distribution of these electric and magnetic fields. For example, here it is a wave-like structure. Now here, the distance between two adjacent waves. This is one wave and this is another wave. The distance between these two waves are these. Or the distance between two adjacent similar points. This is said to be wavelength. This is said to be crisp and they are said to be troughs. So now the wave can be be defined as wavelength can be defined as the distance between two successive crisps or two successive troughs or two successive similar points along the path of the light is known as wavelength. Wavelength. Wavelength means along the path of the light, the electric and magnetic fields are distributed like waves. So the distance between two successive similar points along the path of the light is said to be wavelength. This length may be the distance between two successive crisps or the distance between two successive troughs or the distance between two successive similar points is said to be wavelength. This wavelength is denoted with lambda, inverted y. This wavelength is denoted by lambda, inverted y. And this wavelength is expressed in angstrom units. 1 angstrom is equal 10 to the power minus 8 centimeters. 10 to the power minus 8 centimeters. This is said to be wavelength. Or sometimes it may also be expressed in nanometers. 1 nanometer is equal 10 to the power minus 9 meters. 10 to the power minus 9 meters or 10 to the power minus 7 centimeters. 1 nanometer is equal 10 to the power 9 minus 9 meters or 10 to the power minus 7 centimeters. So these are the units to express wavelength. So light. Light is one form of energy. Energy may be in different forms. Light is one of its form. This light is generated due to the vibration of a charged species in a magnetic field or vibration of a magnet in electric field. This light will travel in a straight line. Along the path of the light, this electric field and magnetic fields are distributed like waves, and these two are equal and identical but perpendicular to each other. This is known as properties perpendicular to each other. So here the wavelength means the distance between two successive similar points along the path of the light is said to be wavelength. Those successive similar points may be the distance between two successive crisps or the distance between two successive troughs is said to be wavelength, and this wavelength is represented by lambda or inverted y, and the units to express the wavelength are angstrom units or nanometers. 1 angstrom is equal 10 to the power minus 8 centimeters, whereas 1 nanometer is equal 10 to the power minus 9 meters or 10 to the power minus 7 centimeters. This is first property, that is wavelength. Now, second property, that is number 2, velocity of light. Velocity of light. Velocity of light means the distance that was traveled by a wave in 1 second is said to be velocity of light. The distance traveled by a light wave in 1 second is said to be velocity of light. Generally, in vacuum or in air, this electromagnetic wave, whatever the electromagnetic wave may be, it may be a radio wave or microwave or infrared radiation or visible light, whatever it may be, it travels 2.998 into 10 to the power 10 centimeters per second. 2.998 into 10 to the power 10 centimeters per second. Generally, we express it as 3.0 into 10 to the power 10 centimeters per second. Or it may also be represented as 10 to the power 8 meters per second. This is said to be velocity of light. Velocity of light means the distance traveled by a light wave in a unit time is said to be velocity of light. And third important property is frequency. Third important property is frequency. This frequency is denoted with a symbol nu. The symbol is said to be nu. Nu. Frequency means if this wave, electromagnetic radiation or light is moving, the waves will cross a fixed point. So, along the path of the light, the number of waves, when they are traveling, the number of waves that crossed a fixed point in a unit time is said to be frequency. Along the path of the light, at a fixed point, the number of waves that crossed, in a unit time is said to be frequency. Frequency is the number of waves that cross a fixed point along the path of the light. This number of waves that cross a fixed point will depend upon velocity of light as well as wavelength. So, frequency nu is equal to C by lambda. Frequency of light radiation nu is equal to C by lambda, where C is the velocity of light, whereas lambda is the wavelength. So, if you know the lambda, you can calculate frequency, and if you know the frequency, you can calculate the lambda, because C is constant for any electromagnetic radiation. And the fourth property, this is third property, and fourth property is wave number. This is denoted with nu bar. Wave number or nu bar. Wave number means the number of waves that spread in 1 centimeter area is said to be wave number. Let it suppose, for example, if wave is moving like this, electromagnetic. So if this is the distance between 1 centimeter, so the number of waves that were present in the 1 centimeter area is said to be wave number. So wave number nu bar is equal to 1 by lambda, and lambda in centimeters. When lambda is expressed in centimeters, the inverse value of that lambda will be equal to wave number. Next, the fifth property of light is amplitude. Amplitude. Amplitude means the height of the crest or the depth of the trough is said to be amplitude. This is said to be amplitude, and this amplitude is denoted with psi, the symbol psi. This is known as amplitude. Let us do some problems basing on these properties. Let us do some problems basing on the properties of light. Number 1, calculate the frequency of light radiation of wavelength three thousand angstroms. Calculate the frequency of light radiation of wavelength 3000 angstroms. Here, the relation between frequency and wavelength, we have already discussed that frequency of a light radiation is equal to C by lambda. Nu is equal to C by lambda. Here, C is the velocity of light, whereas lambda is wavelength. Here, while doing this problem, units are most important. We should take in same units. Wavelength and velocity should be in. Generally, we express wavelength in angstrom units or in nanometers. So, first of all, we have to convert it into centimeters or meters. So, if you take velocity in meters, you have to convert into meters. If you have to take in centimeters velocity, you have to convert, the lambda is also in centimeters. We know that 1 angstrom is equal to 10 to the power minus 8 centimeters. 1 angstrom is equal to 10 to the power minus 8 centimeters. Now, 3000 angstroms is equal to 3 into 1000 into 10 to the power minus 8 centimeters. 1000 means 10 cube. 1000 is nothing but 10 cube into 10 to the power minus 8 centimeters. That is equal 3 into 10 to the power minus 5 centimeters. 3 into 10 to the power minus 5 centimeter. That is lambda in centimeter. 3000 angstroms means 3 into 10 to the power minus 5 centimeters. Now here we converted angstroms into centimeters. Then velocity of light, this is lambda. Velocity of light, C is equal 3 into 10 to the power 10 centimeters per second. Velocity of C is equal to 3 into 10 to the power 10 centimeters per second. Now, substitute the C and lambda values here in this expression. Nu is equal to C by lambda, but C is equal to 3 into 10 to the power 10 centimeters per second, whereas lambda is equal to 3 into 10 to the power minus 5 centimeters per second. Or this can also be written as 3 by 3 into 10 to the power 10 into 10 to the power minus 5. This minus 5 will become plus 5. So, 3 cancel. This will be 10 to the power 15 per second. 3 into 10 to the power 15 per second. So, this is the frequency of a light radiation, which wavelength is 10 to the power 3000 angstroms. Again, same thing. Calculate the frequency of light radiation, which wavelength is 2000 angstroms. 2000 angstroms. So wavelength is equal to 2000 angstroms. So now we have to convert it into centimeters. So 1 angstrom is equal to 10 to the power minus 8 centimeters. Therefore, this can be written as 2 into 1000 into 10 to the power minus 8 centimeters. 1000 means 10 cube. So it can be written as 2 into 10 cube into 10 to the power minus 8 centimeters, or maybe 2 into 10 to the power minus 5 centimeters. Because 10 cube into 10 to the power minus 8. This is minus 8 and this is plus 3. So here it becomes minus 5. This is lambda. Next, C is equal to 3 into 10 to the power 10 centimeters per second. This is velocity of light. It is constant. Whether it is in air or in vacuum, the value is same. Now, they are asking for frequency. We know that frequency nu is equal to C by lambda. Nu is equal to C by lambda. C is equal to 3 into 10 to the power 10, whereas lambda is equal to 2 into 10 to the power minus 5 centimeters. So on substituting these two values here in this expression, you will have 3 into 10 to the power 10 by 2 into 10 to the power minus 5. So here this 3 will become 1.5. 3 by 2 is nothing but 1.5 into this 10 to the power 5 becomes 10 to the power minus 5 will become 10 to the power 5. Then it may be 10 to the power 15. Or it can be written as 15 into 10 to the power 14 per second. So this is the way to calculate frequency if you know the wavelength. Or similarly, if you know the frequency, you can easily calculate the wavelength of a light radiation. The wavelength of light radiation which frequency is into 10 to the power 14 per second. 2 into 10 to the power 14 per second. So here we have frequency. Frequency nu is equal to 2 into 10 to the power 14. We know that the velocity of light c is constant. So c is equal to 3 into 10 to the power 10 centimeters per second. Now nu is equal to c by lambda, or lambda is equal to c by mu. So c is equal to 3 into 10 to the power 10 centimeters per second by nu is equal to 2 into 10 to the power 14 per second. So 2 1.5 times, so it can be written as 1.5 into this 14. When it comes to this side, it can represent 10 to the power 10 into 10 to the power 14 minus 14 centimeters. So it can be written as 1.5 into 10 to the power minus 4 centimeters. So here we have lambda in centimeters. Now we have to convert lambda into angstrom units. So while converting angstroms into centimeters, we multiply with 10 to the power minus 8. So to convert centimeters into angstroms, you have to divide with 10 to the power minus 8. So lambda is equal to 1.5 into 10 to the power minus 4 by 10 to the power minus 8. This 10 to the power minus 8, 1.5 into 10 to the power minus 4 into 10 to the power 8. This minus 8 will become plus 8. So here 1.5 into 10 to the power 4 angstroms, or this will be 1.5 into 4 zeros. 10 into 10 into 10. So it can be written as 15,000 angstroms. 15,000 angstroms. So dispersion of light. Dispersion of light is another important property of light. The white light which we are seeing is a mixture of 7 colors. They are violet, indigo, blue, green, yellow, orange and red. That we call it as VIBGYOR, VIBGYOR, VIBGYOR. V stands for violet, I stands for indigo, B stands for blue, G stands for green, Y stands for yellow, O stands for orange and R stands for red. This white light is a mixture of 7 colors. When this white light is passing through a prism, when it is coming out of the prism, this white light will divide into 7 colors, because each color will have a specific wavelength. Because the red color wavelength is different from yellow color, and yellow color wavelength is different from orange color, and it is different from green color, and its wavelength is different from indigo, violet, etc. Each color will have a specific wavelength. Basing on its wavelength, when it is coming out of the prism, that light will have certain angle, reflection angle, and travel in a specific direction. Because of that, these 7 colors were separated. The separation of these 7 colors, the grading of this light according to their wavelengths, is said to be dispersion of light. So this dispersed light, if it was recorded on a photographic plate, if you recorded this dispersed light on a photographic plate, you will find some lines on it. These lines are said to be spectra. These lines are said to be spectra, and each line stands for a specific wavelength. Each line stands for a specific wavelength. So that is spectra. Spectra means a colored picture. Actually, the spectra is not a colored picture. Just certain lines on a black screen, or a white lines on black screen, or black lines on white screen. That we call it as a spectra. But those lines on the spectra will indicate a specific wavelength. The instrument that was used to record this spectra is said to be spectroscope. So, while studying the atoms, these spectra are very much useful, because each atom will emit a specific lines in its spectra. With the help of those lines, we can calculate the position of electrons. So these spectra are very much useful to study the behavior of these atoms and to understand the structure of atoms.